Hi, and welcome to part 6 of the audio sequencer project. So last time we ran into a little bit of a problem there, and so I thought it would be helpful for review sake and also to show how I solved the problem, just to go over this bit. What we're really working on right now is we have a cursor, and it's going to detect our sequencer dots. It's going to detect when it hits one of these sequencer dots. So, okay. Every time it hits one of those dots, it's gonna detect. So this is the bit of code that does that. Cursor detect SAMP dots. And let me just walk through it just for review and also just to connect us back up to the problem we had and to show you what solution I came up with. So here we have a for loop here, and it says we have an array of 16 nodes. Those are all the x locations, or the x locations of our 16th node markers. And it's going to scroll through, it's going to loop through this entire array of things. And it's going to say if the cursor, so this moving cursor, cursor x, if the x location of the cursor is greater than that particular 16th marker location minus 4, so 4 pixels to the left and 4 pixels to the right of the marker, run what comes next. And the next code is if samps I is equal to 1. So we have another array of samples markers. So those are the dots. And they're all, I think, marked 0 or -1. I forget what they are defaulted to. Well, let's see. In any case, that's fine. Not finding it right now, but it's okay. But anyways, they're defaulted to something like 0, let's say. And if they happen to equal 1, that means there's a dot on it. So it'll only report something for the markers that have little dots on it or checked. And if trigger. So we have this whole trigger bit going on. So if trigger is true, so that's basically, oops, what's going on here? Sorry about that, a little hiccup. So basically that's just assuring that we only trigger one sample or only send one message or do one thing, because it could actually be in this area for more than one frame. So you're going to get 3 or 4 reports. So this is a bit of a gate, if you recall. And so it says if the gate is open, just shut the gate so that we don't get more than one report. Okay. And right now we're not doing anything right now. We're going to say we're just going to print something. Okay. Just to show that we've triggered a sample. Now, let's see. So this bit now is to reset the trigger. So this is great because it prevents you from sending more than one sample. But if it is, if once it's triggered to false, once it's shut, there's nothing, you can't trigger any more samples. So this bit, these two bits open up the thing. Okay, so this is sort of the opposite of what this is, or the inverse, right? So if 16's dot length, so now what we had to do is to split into 2 parts because the last one's a special case. The very last dot on our sequencer is a special case because it goes back to the beginning, right? So here we got for all the dots except for the very last one, -1. If this cursor x is greater than 16 plus 4, so basically, if it's greater than, if it's outside, if it's past the last marker, and if it's before the next marker here, right? Then let's go ahead and open that gate up again. So before the next marker comes again, if it happens to be, marked with a dot, then the gate will be open for it to print something. Now, this is where we have the problem here. The last case scenario there needs to be taken. And I was going through all this sort of complicated stuff, but in the end, I figured out that all I really needed to do was to just treat it as it was supposed to be treated, and basically say that if the cursor is greater than the next one plus 4, and the cursor is less than r, which is the range of the whole of right, is the right location of the bounding box. So basically, it's almost the same thing, except I just forgot that I just had to track for basically when the cursor gets to the very end. So this is R right here. So basically, if it's outside the purview of that one, 4 pixels past this last one, but before it gets to the very end of the thing, before it switches over to the beginning. Because right there, anyways, is the beginning, it's going to hit. Yeah. Okay. And then I had to make a couple other little mini adjustments about the way that the cursor goes. So it's actually now the cursor is being mapped from L-4 to the right. So basically, it gives 4 pixels. It starts again 4 pixels to the left of this edge, so that it gives it a chance to open up the gate for that thing, or to trigger that. Okay. So hopefully that works. Something. Yep. And then hopefully our last one works as well. Something. Yep. And then only one. So if you look down here, only one message is being triggered for each one. And this is pretty fast. This is, what are we doing at? 200 beats per minute. So that's probably as fast as I'll ever go with this sequencer. Something. Good. Okay. So that solves our little problem there. And hopefully I didn't torture you too terribly by taking you through all that. Okay. So now let's move on. So now, in order for us to do something here, what we really want to do, instead of just printing something, we want to trigger a sound. And I've decided in the sort of my overall architecture conception is that I'm going to use this processing as a graphic interface, make a sort of graphic sequencer with this animated cursor, because it's a nice way to learn programming, and it's an also pretty easy platform to do things like this. But in fact, I'm going to use a totally different program to generate the audio for it, which is better suited to that. And that's SuperCollider. It's a another programming environment based essentially in Smalltalk language, but it's very customized. And that's going to be used for our sampler, actually the sound producing mechanism. So here, basically, we're going to use this connective tissue open sound control, and you can look that up and investigate that on your own. But basically, it's like MIDI, and it's just much more flexible and customizable. It's basically like a totally user configurable MIDI. All right. So we can send OSC messages right here, because this is when our actual trigger happens. So let me go ahead and show you how to set up OSC. First of all, we're going to want to import the library. Now, I already have it, but if you want to import the library from processing, you go to Sketch, import library, add library, and then you can do something like OSC. And you want this OSC P5. Okay, so you're going to, there's a new version available. So why don't I update that? But if you don't have it yet, you would say install. Okay, so I'm going to do OSC P5. Brilliant. And that should be done. It could be that I need to restart, but I'm not sure. Let me save this as sequencer 8. And we'll say OSC. Okay. All right. So, so we essentially have a library. Now, we may need to quit and restart. So let's do that. Let's restart processing, just in case. And we'll open recent, which will be the sequencer 8. Okay, and make that big. Now, probably the easiest way to really use those libraries is to go to the examples. And I always do this anyways because I'll forget. I don't have all this stuff committed to memory. So if you go to examples, you go to contribute to libraries. And then you go here to OSC P5. And you'll have a number of different things. They're all worth checking out. I'm going to just use this send receive as my template. So I'm going to sort of pop that over there. All right. And it's nicely commented. I always like that. So the first thing we need to do is we need to import the libraries into our sequencer so we can use. And it, in fact, has two NetP5 OSC P5. Just going to copy that bit of text there, pop that in. So now I'm going to be importing the libraries there. And then there's a few things to set up, and I'll go through it. So the first thing is this OSC P5, OSC P5. So these are variables, in fact. Oops. And I'm going to make a little comment and say setup OSC. And then I'm going to say, make a variable. So OSC P5, once we have the library, we can declare a data type OSC P5, which essentially is the machine to let us send these messages to other apps or across the network to to somewhere else in the world. You might have heard of TouchOSC. That's something you can do on your mobile phone as well, and you can send and receive using that. Okay. Anyway, OSCP5 sets up the machine so we can actually communicate in Open Sound Control. And here they just call it OSCP5. You can do that. I often call mine me OSC. Okay, that's just a variable again under the name EOC, setting up the OSCP5 machine. Okay, so I can use it in my sketch. And then we have a net address. That's a location that I want to send to. And again, we're just setting up the variables here. We're just declaring that we're going to have a net address. ADDRESS, and I'm going to call my sclang because I am sending to the language side of the SuperCollider. So I'm going to go ahead and do that. Now in setup, we're going to have to set up our initialize our OSC machines. So set up OSC. Okay. And I'm going to say me OSC. Okay. And equals, and then set it up as a OSCP5 machine. New OSCP5. This referring to the root sketch or my sketch. And then the second argument that it takes is the port number that I'm going to be receiving messages at. This is me, my home, my sketch thing. And you can we're not really receiving messages. We might at some point. So you can sort of put any port really. They say 12,000, that's fine. We'll just do that. Oops, not 120,000. And then we're going to set up the remote location or the place we're sending to. And in this case, it's called sclang. And then we're going to say equals new. And it's a net address. And it takes a certain amount of arguments. So the first argument is the IP address. And I'm just sending to my local host. I'm just doing it locally here on the same computer. Now, if you, for example, had a SE server or language or just an SE SuperCollider running on some remote computer, you can put a different IP address. This is what makes Open Sound Control so handy. But I'm going to put 127.0.0.1, which is your standard local host. That means it's just going to send to myself, to my local computer. And then a port number. Now, I just know that SuperCollider language, the language side, which is the part I'm going to be sending to, is hard-coded IP address, which is 57120. So that's the port number. Okay, and it's using UDP, just a protocol to send messages. Okay, so I have my sender, my remote location set up here, sclang. We have my machine to send OSC messages set up, and that's more or less it for setting it up. So now I'm able to use now OSC. Now I have to just set up the area where I actually send the message. So we want to send a message when the cursor detects one of the dots, right? Which is right here. So we can just comment that out. You might need to use it again later on. And then we'll just look at the syntax here to send a message. Okay. So basically, you're setting up a message as local variable. You're sending an OSC message right here, OSC message. And we'll call it MSG for short. And then we're going to set it up, initialize it, and declare it all in one go here. And it's going to be local to this area right here. So we're going to say new OSC message. Okay, and the argument it takes is the tag. So unlike MIDI, which already has sort of a preset syntax and defines like channel numbers and such, note numbers, et cetera, you can basically define your own message. And OSC just asks that you use this slash, this /, and that's to designate that that's an OSC message. You can call it whatever you want. So I'm going to call it SAMP, something like that, SAMP on or something. Okay. And so basically the idea is that my receiver will look for this tag, this /SAMP on tag, to do anything. And I'll show you that in just a minute. Okay. So this argument then is the tag for the OSC message, and it's this MSG is the name of the OSC message now. So I'm going to go msg.add. Now then you can just continue to add data. Now in our case, in fact, we won't really need to add anything, because once we basically send the SAMP on message, we're just going to react to that. our audio program is just going to trigger a sample once it receives a sample on message. So I don't really need to add any data. Now, adding data, for example, might be for if I want to send a tone, I might send the frequency of the tone or something like that. Or I might even, if I wanted to make my sampler kind of fancy, I might have sort of a different banks of samples, and the added message might be use sample bank 1 or sample bank 2. But in this case, let's keep it simple and just not add a message, and maybe we can augment that later. Okay, and so I've created the message. I'm going to send the samp on message, and then now I'm just going to send it actually. So me OSC, that's my machine. That is the OSC Open Sound Control machine, and then we're going to use that machine to send. And then the 2 arguments it takes are what message you want to send. Well, it's MSG, the one defined above, and where do you want to send it? We're going to send it to SuperCollider, so SC lang. Okay, and that's it. So really, 1, 2, I guess 3, 4, 5, 6, 7, 8, maybe even lines of code, but they're not even lines essentially. And then you have a very powerful sort of message sending machine. So let's save that up. Let's run it just to make sure we didn't make any typos. Seems like we're okay there. I have an issue with my network, so I'm going to just disengage my network there. Just turn that off. 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 Apply. Okay. All right. So at least it works. That means, and it's not giving me any sort of message yet, but we'll see soon. Okay, so let's stop that now. We can get rid of our example. We don't need that anymore. We make sure we save that. And now it's time to open up SuperCollider. So let's open up SuperCollider. And let's just set up very basically just a tester. So I'll just save that as OSC tester. Okay. And where was I saying this? Was in tutorials. Yeah. Okay, I'll save this as a SuperCollider document. Okay. And basically, I can just set up something to respond. So the little machine that will receive and respond to messages is called OSCDef. Okay. And I'll go through this in more detail in a future tutorial, maybe probably the next one actually. But right now I'm just going to set it up. So this is just a key, this is a test. And I have a function, which basically is the thing that's run to respond to when I get the message. And then the message I'm going to get, and we said it was samp on, right? Samp on. And then just close out that OSCDef. Okay, and actually I can probably just put all this on one line, make it easier to evaluate. Now what do I want to do? I'm just going to print. I'm just going to say works. Okay. So when this receives the message samp on with this /, it's just going to post in here in my post window works. All right. So if I evaluate that, it's ready to go. And here's a moment of truth. Let's run that. Okay. And let's put a dot there. Oops. And it works. Brilliant. We'll just be double sure works. Works. Awesome. Okay, that's great. So we can save this just for posterity's sake. All right, well, that was actually a nice short tutorial. I'll wrap that up there. Basically, what we covered is setting up our sequencer to send OSC messages. And then all that work we did before in trying to get this cursor detection thing just right is paying off, because here's where the rubber hits the road. And we're actually sending this message. So you can imagine that right now, in our next tutorial, we're going to make a sampler and send samples. But, you can send this message to anywhere and have all kinds of things happen, depending on, based on the sequencer. So you can sequence a bunch of different things, Great. Okay, I'll end this tutorial here. And the next one, we'll get onto the SuperCollider part and actually make a sampler.